Hello, scholars. I'm coming at you from the supply closet in the back of the school because there's no quiet room in this building. And we're going to talk about oil consumption and the Nexus. All right, so we've talked about fossil fuels a little bit in the climate change unit, but we're going to focus on it again, more of a like, why do we even use this stuff? Like, how is it produced? So, oil in particular is our main energy provider in the world, and consumption of it is just continuing to rise, even though there's more people talking about how we could not use oil or natural gas or coal. Like, those things are still used and still desired in the world. So we still need to talk about why are they used and how do we get them. So how would you get oil? Well, the easiest way to get oil is if there's a big reserve of oil, and a reserve is an amount that you know is there. All these reserves are underground. Some of them are under the ocean floor. But like in Texas, old school Texas oil wells, you could really like stick a pipe in the ground and oil would come out of it. So you just like drill that oil and it's easy peasy. Then you send it to a refinery and it turns into the different hydrocarbons that you would use. Anything from gasoline to motor oil to the oil we use to make plastics or petroleum jelly or all sorts of other things. What's harder to do is to do things that are like offshore drilling or drilling in more remote areas. And so these oil rigs off the coast are gigantic. They're like little towns. And they have a pipe that goes through the ocean and then through the ocean floor to get at reserves that are underneath the ocean floor. The hardest way to get oil, and something that the US has been getting better and better at, is horizontal drilling or hydraulic fracturing or fracking. Fracking is a little bit complicated. Actually, it's a lot of bit complicated. But basically, there are little patches of natural gas, especially, but sometimes oil, that are underground in deep layers pretty much everywhere. But it's not enough to just put a pipe down there because it would be mostly just dirt. So what companies have been getting better at is they drill down and then across, and they shoot chemicals and water at high pressures, and it creates cracks, so fractures, using water, thus the hydraulic. So you create these fractures, and then when you pull the chemicals in the water out, then all these little gas bubbles and oils will go into the cracks and go up the pipe. And then you can collect it together, and it's just like you drilled oil or natural gas out of a reservoir. It just takes a lot of extra work, and there's some negatives to doing fracking. So we'll talk about that in class. So it would be way easier for us if we still had enough oil where we could just throw a pipe in the ground and get it, but that's not how it is anymore. Oil is very difficult to drill. So we do deep sea drilling, where companies are looking at drilling in the Arctic. Shale sands are when there's like oil that's not very high quality and it's mixed with sand. This is what's drilled a lot in Canada, and that's why they want to make a pipeline down to the southern United States, because our refineries can deal with shale sands and theirs can't. So there's tactics being used to get more oil and natural gas. It's not easy anymore. And that causes problems. As you can see down here, number one most important thing that's bad about oil is it's very yucky. It's nasty. So especially if there's an oil spill, it's bad for the environment and human health, and it's just nasty. Carbon dioxide is a greenhouse gas that's created from burning fossil fuels. So we talked about that already, especially with coal, but sometimes with other products too. You can have other substances mixed in with those hydrocarbons that you're burning. So especially sulfur in coal. One of the reasons that China has such bad pollution in their cities is that their coal is very sulfurous. So when you burn it, it creates sulfuric acid that creates smog and creates acid rain. Oil is explosive, which means you could die from it because it's a big ball of fire. So that's bad news. It's also very difficult to transport. So we've had many examples of oil spills in the U.S. Tankers that have run aground in Alaska, like the Exxon Valdez disaster, which spilled oil all over Alaska. Most recently, we had the BP Deepwater Horizon spill, where this oil rig caught on fire and collapsed, but the pipe was still there, so the oil kept flowing out of the bottom of the ocean and was just leaking everywhere throughout the Gulf of Mexico. So that one was bad news. So if oil is so yucky and so explosive and so difficult to get at this point, why do we still use it? So we're kind of in this situation where the world is just kind of organized in a way where oil and natural gas are easier to produce and get to their consumption points. So 80% of the world still uses these things. So everyone's kind of used to using oil. Because there's so much that's bought and sold and there's such a need for it, it means that it's relatively cheap compared to other fuel sources. There are transportation methods already for getting these things to where they need to go. So these oil rigs are built already, and the pipelines are built already, and the tanker trucks and the tanker boats and all these things are invented, and they're on the move, and they're already selling and producing these fossil fuels. So you don't have to build a new infrastructure like that our infrastructure is built to support oil and natural gas production and getting and burning those things for fuel. You could think of our cars are built to use gasoline. Our electrical grid is built around coal and natural gas factories. We don't have our power grid located centralized in Arizona to capture the best solar energy. We have them ready to collect coal and oil to burn. That's kind of how our system is. I said click. Okay. So there's such a thing as peak oil. So there have been lots and lots of people since the 50s trying to figure out, will we ever run out of oil? And so peak oil is not when we use our last drop of oil. Peak oil is the maximum rate of extraction, which is a fancy way of saying that's when we reach peak oil, that's as much oil as we can, that's the highest amount of oil we can produce at one time. So at some point we're going to have to cut production because there's less and less and less out there for us to drill or to create. So at that point, that's when we're going to start feeling a pinch because, like I said, 80% of the world is using oil and natural gas. So once we lower production, that means the price is going to go up and demand will continue to be high. So it'll start getting very expensive and the world will start freaking out at that point. If demand went down, then it wouldn't be so bad. But this is consumption. This graph is consumption by country. So OECD is like rich countries basically. And so rich and poor countries alike are continue to use more and more fossil fuels or are expected to use more and more fossil fuels. So if we start running out and the expectation is that the world wants more, then that's going to be a problem. So what could happen politically? Countries that sell oil will have recessions. So we're going to talk about Venezuela in class. They're the best example. Prices will go really high. So not only will that create conflict between countries, but it will mean that everything we buy from like gasoline for our cars, but also things like plastics and clothing and food will get more expensive because all the packaging and the like transportation that we use to get those products where we want them will be more expensive. And countries that have prepared for using alternative fuels will probably see a benefit from this. Environmentally, it could be a problem because countries could find ever more dangerous ways of trying to get the little bit of oil that there is in the world. Hopefully the positive that could happen is that hopefully renewable energy would become cheaper than oil in the future. Once oil gets so expensive, then it'll make economic sense to invest in renewable energy. And then as investments improve and as technology improves, then renewables will become cheaper. And we can hope that someday one of our ancestors will be able to see the world heal from climate change. So as you could probably tell, I wish that we used more renewable energy for a lot of reasons. So why not? Why don't we just say, hey, oil's yucky and it blows up, so let's use something else? There's lots of good reasons why we don't use renewables more often. A lot of it comes down to it just being very expensive. And not only are they expensive, but they're not as efficient as using oil. So they, like solar photovoltaic cells, for example, at best can absorb about 40% of energy from the sun. It's more like 25% usually. So if you're only getting a fourth of the energy from that source, like that's not very efficient. Wind turbines lose a lot of their energy in the process of creating electricity. So they're just not super efficient. So they're expensive. They don't create as much energy as you want. They're dependent on geography. So you need sunlight for solar. You need windiness for wind energy. You need water for hydropower. You need shoreline for tidal power. You need geologically active areas to get geothermal heat. Like Iceland gets a lot of geothermal heat. We do not. And they also are intermittent, which is a big fancy word for they're not always available. So most energy is used at night, and that's when the sun's not out. So you can't really use solar energy at night. So things like that are all problems with converting to renewables. Right now, renewables are a support more than anything else. We'll talk more about renewables in class. We're probably going to do a Socratic seminar on renewable energy, so you can look forward to that. Next up, the Water Food Energy Nexus. I'll be honest with you, this is new to me. This is new to the curriculum, and although it makes sense to me, I hadn't heard it talked about this way, so I'm going to do my best, but I think it's pretty self-explanatory once you get the diagram down. So, the Water Food Energy Nexus, which I'm now going to call the Nexus because I don't like saying water food energy. It refers to the relationship between our ability to grow food, to have water security, and to create energy for some population. So it could be your town, it could be your state, it could be your country, it could be the world. So that nexus is just like, this is how all these things relate. So you can follow these nifty diagrams I put on each page. They're all slightly different, but say the same basic thing. We need water for energy. We need energy for food. We need, food is going to impact water availability. Water is needed to make food. Agricultural land might be used as biofuels. Energy is used to get water. So they're all like tied together. So here's an ever more complicated graph of how these things interact with each other. You can read for yourself. I'm not going to read to you. But again, what is super, 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 super important about this nexus thing is that they all are interrelated. You can't really, like we did earlier in the unit here, you can't just talk about water and ignore that food production and energy is a thing. Like that Cape Town example. When I talked about water, we talked about how they were growing food to ship to Europe because that was using up water that they had. We also talked about how they couldn't really use desalination plants because it took so much energy to run those plants to get water. So it's silly to just talk about water and not realize that food and energy are part of this equation. All right, so when they ask you questions on this resource unit, IB is going to expect you to keep these relationships in mind. Even if they just ask you a question about water, you better be thinking, is there a way for me to connect this to food and energy? Or is that country, do they have some policy, food, water, or energy policy that affects the others? So I got tired of even writing it. So the Nexus and climate change. So last unit we did climate change, and we talked about all the ways that the climate is becoming more extreme and more difficult to predict. And when you're trying to figure out the close knit relationship between water, food, and energy, and then you throw in that climate is being variable and is just being weird, it makes it really hard to make plans. So climate change affects a lot of stuff in the water, food, energy nexus. You have extra heat, so you have people using more energy for air conditioning. You also, that affects farming. Farmers might have longer growing seasons, but they might also have drought. So drought is going to affect how much food we can create because of irrigation. It also affects how much water we can have. Maybe it affects our energy because we're using energy to create desalination plants to get water instead. Evaporation from the ocean or from rivers means less water. Extreme weather could knock out power grids. It could knock out food production. It could lead to saltwater intrusion in fresh water. And natural disasters, forest fires, all these things could disrupt our ability to grow food, get water, or create energy. All right, so we're going to talk in class in about a week about how countries are using this Nexus framework to think about how they're going to get resources for their population. But just in the back of your mind, you should be keeping in mind that climate change is going to throw a wrench into this, that climate change is going to make it so that you can't really plan for everything that's coming. All right, so that was the last slide. That was a lot of text, so I'm sorry about that. But I'm just trying to lay out everything for you that might come up. We're going to try to have a lot of discussions around this, so please bring questions, bring examples. If you see videos, articles, anything, like bring them in so that we can have interesting talks about this. All right, bye y'all.